we have this integral, which might seem a little confusing on how to integrate, because it looks a little bit different than some that we have practiced. But we will calculate the exact value, and then we will estimate using both trapezoid rule and Simpson's rule. Okay, there's kind of a little trick you can use, but we can use substitution here to integrate this function. One place we look for an inside function is in the denominator. So I will let u be y minus 7, and then du is dy. Now you might say, well, we have a problem because I have a 5y in my integrand, but we may solve for that. So here, if you see u is y minus 7, we can solve that y is, move it over here, u plus 7, okay? So then I can write 5y, for example, as 5u plus 35. Now, let's see. We will change our bounds. When y is 0, u is -7. And when y is 4, u is -3. Okay. So we have an integral. It goes from -7 to -3, and then we have 5u plus 35 over u du. Okay? Every piece of my integral, right? The y minus 7, this here became a u. Up here, this became 5 times u plus 7, the dy du, and then my bounds are changed. So every single piece became something of u. Okay, wonderful. Now, this looks significantly better than the integrand we began with, because we may break it as a sum of 2 integrals. So now we have an integral -7 to -3. The first term, 5u divided by u, is 5, and then we have a 35 over u. Now we're ready to integrate. We integrate, we have 5u plus 35 ln absolute value of u, and all of this evaluated between -7 and -3, which becomes, we have -15 plus 35 ln of 3. Then we subtract a -35, so minus 35 becomes plus 35. And then we have minus 35 ln 7. And altogether this becomes 20 plus, if we use properties of logs, we have 35 ln 3 over 7. Okay? So this is my exact answer. Just like this. Wonderful. Now comes our estimation. And I do have another video that has trapezoid rule and Simpson's rule, but it's always good to practice again, so you can see that in the Calculus 2 playlist. First we will do, well, both of these have n equals 4, and our interval is 0 to 4. So delta x, b minus a, over n is 1. And our partition P, you start at the lower limit of integration, which is 0, and you start moving forward by delta x until you get to the upper limit. And you can see we have 1, 2, 3, 4 subintervals. So this works out very nicely. And now the trapezoid rule The formula, maybe I will write this in blue. You must just memorize these. Trapezoid rule has a delta x over 2, and then we have f of, in this case it'll be 0. All the middle ones get 2's. F of 3, and then the very last one has 1 in front, f of 4. Okay? The other one we will use Simpson's rule. It looks very similar. The only difference is we have delta x over 3. We start off with coefficient 1, and then we have alternate with 4's and 2's. So 4, then we would have a 2, f of 2, and then a 4, f of 3, and then we end with coefficient 1. Okay? So these are the differences between trapezoid rule, where we're actually approximating the function with little line segments, and Simpson's rule, where we approximate the function with quadratic pieces. Okay, now here's what I will do. Let us write this here. This equals 20 plus 35 ln 3 over 7. And then I will erase. So I have erased, but I also changed. I had delta x, and if you look at the integral, the variable is y, so I changed to delta y just to match the variable. Now, over here I will compute, for example, we see the function value at every point in our partition. So I need f of 0, I need f of 1, f of 2, f of 3, and f of 4, and then whether I'm doing trapezoid or Simpson's, I'm going to use both these values. Well, here's my function. F of 0 is 0 divided by -7, which is 0. F of 1 is 5 over -6, or -5 over 6. F of 2 is 10 over 2 minus 7 is -5, which gives me -2. F of 3, we have 15 over -4. And finally, f of 4, we have 20 over -3. Okay, now let's come back to our rules here and put everything in. Delta y is 1, so we have a half. We have f of 0 plus 2f of 1. Oh, we're going to have a lot of minuses. You notice all these are negative. So we have 2f of 1 is -5/3. And then we have 2 here, -4. Then we have 2 times, this is f of 1, 2 times f of 2. We have 2 times f of 3 would be -15 over 2. We have 1 times f of 4. Okay? I'll leave it like this for the moment. You could get a common denominator, add. I'm going to be using a calculator anyways. Let's just leave it like this and move on to the Simpson's rule. In this case, we take delta y over 3. We have the first, all these are also minus, so we have minus, maybe I will just leave this unsimplified, will be 20 over 6 minus, now there's a 2 times the next one, and then there's a minus, there's a 4 times f of 3, and then we just have 1 times f of 4. Okay, now at this point, as I said, you could get common denominators, but let's see what I got in my calculator. For this one, it's approximately minus 9.9167. This is approximately minus 9.66, let's see, 67. Try and keep the same number of digits. And if you put this one, the actual value, in your calculator, you get minus 9.6554, okay? So the approximations that we got from Simpson's rule, it's here. Trapezoid rule, it's here. And then this is the actual value by finding an antiderivative and evaluating at the upper and lower limits of integration.